So this is Math 21. I'm tired of trying to figure out what day it is. I know this is the third week, the second day. It's day 6. I probably should have called it day 4 lecture, but I'm fucking done with that. It's too hard to fucking remember and calculate. This is on sections 2.2, 2.3, and 2.4. This is our graphing stuff. Graphing sections. Before I get to that, I want to let you know about what an offer I have for you. Well, let me just put the offer first. On Monday, it's a holiday. From 8 a.m. to 10 a.m., I will be at the Starbucks on Caldwell and Demery. In Visalia. They know me by name there by now. I don't live next to them, but since I often tutor students from Visalia over there, that's where I go. Like, I like that Starbucks better than other Starbucks. And I've only opened this offer to stat students. I haven't told my STEM students about it yet. But I am not showing up if no one texts me or messages me or emails me. Texts, emails. I don't know if you join Discord and fucking send a message there. Messages me. Because I'm not dragging my ass out of bed on my holiday if no one else is dragging their ass out of bed on their holiday. I'd rather get it done in the morning, get it done with. That way the rest of the day is ahead of me. I still like to have my free days. In the future, I'll probably make this offer available on Sundays. For some people, it's in church hour. Saturday mornings, I'm already, like most of my Saturdays are already booked, and I don't want to, like the end of the holiday is Sunday. I don't want my evening or afternoon on Sunday wasted. That's fucking movie time and wife time. So, if you really need help in the future, on the weekend outside of it, I'll be at the Starbucks if you let me know. I'll remind you guys on future weeks. Okay. Again, someone's got to message me that they're going to show up. That'll be this Monday because it's a holiday. So let's go take a look at what we're looking at here. I'm going to come over to Pearson. I'm going to log back in. And I went to StatCrunch. And I went to my data set. We're looking at the one. We're looking at the one we did the other day. And I had recommended you check out BarPlots and histograms for age. So we're going to do that right now. BarPlot with data for age. And I'm going to bring up the menu for the histogram at the same time for age. And we're going to look at the two things, what's going on here first. So on the bar plot option, I have a lot of options. I can choose any of these columns. On the histogram, I can only choose 4 columns. If we look at those columns right now real quick, response, age, shoe, and height are the only columns that have numbers. Histograms require numbers, but bar plots we can do with any data. And I'll write this all down in a second, but I think showing it to you there will help. We are going to talk about bins a little bit later today. This one, histograms allow us to pick the bins. Both of them, we can say frequency or relative frequency. Oh, this one's even got more options. Percent. We can both say value above bar. On bar plot, I have an option to change the order. I can do value by ascending where the numbers go up. I can do, or the letters go up, the first letter increases A to Z. I can do descending where it goes Z to A or high number to low number. If you do worksheet, it goes in the order they appear in the worksheet. So it could be completely out of order. Histogram doesn't offer that. And they both allow us to do different colors and shit like that. They both have horizontal lines. We'll see what those are in a second. I'm just going to click compute. The bar plot asks us about binning. I don't want to do it yet. Oh, fuck, I said yes. Oh, well, we're fucking doing it. And I guess I'll click compute here. And it does its own bidding here. So, what kind of differences can you guys see between these two? The bar plots on the left, the histograms on the right.
One's by 10, so they're by 20. What's the age?
It looks like it, but if we actually look at an individual bar, these are actually going by 5. But different widths, right? The numbers they cover are different. That's a fair assessment. Anything else?
Looks like they hit the one on the right a little tighter,
What do you mean by tighter?
more compacted, more. Just obviously gaps.
There's more bars.
Compared to.
There's no gaps, right? The columns actually touch. Now there is a gap right here, but that's just because there's no data in that area. Here, there's gaps in every single one. Bar graphs have spaces between the rectangles. Histograms don't. Now, while I haven't set it up right here, bar graphs can go sideways. Histograms can't. Bar graphs, and I'll write all this down in a second. Well, fuck it, let's write it down now. Let's look at things that are in common. So between bar graphs or bar plots and histograms. Let's talk about things they have in common. Things that are specific to bar plots. And things that are specific to histograms. For those of you that care, Melinda has successfully groveled her way in allowing notes on the midterm. You can thank Melinda for being allowed to use your notes on the midterm. This offer does not extend to the final. But the final has no math on it. All the math is done by the computer, and you don't even need to use the computer. I will print out the results from the computer for you. All you gotta do is, this is what ends up being like taking a psychology course. You're answering questions about it, but they're all statistics related. That's the final. The midterm definitely has math on it. It's a lot of math. I know. It's a fucking math course. If you didn't have any math problems, we couldn't call it a math course, right? Things in common. They both have rectangles. That may seem like a no-brainer, but does a pie chart have a rectangle? No. They both can do frequencies or relative frequencies. That's all they have in common. Now they have things that look similar, but like they both have bars, but on the bar plots, the bars don't touch. And on histograms, the bars do touch. We saw that histograms had to be in order. They increased from left to right. It was forced, but on bar plots, we had the option of doing any order. I don't know why I wrote bar plot again. It's the fucking head of the column. Doesn't Hell's Bells start out with a long gong?
Yeah.
I've fucking played that like 5 minutes before a test. Cause it sounds like a funeral bell. And I've had people walk in and be like, oh goddamn, you fucked up. And I just giggle.
Can I share a funny story real quick?
Yes, you can.
Today I was at work and Hell's Bells came on the radio. It's in the mail room. First I thought, oh, cool. It was For Whom the Bell Tolled. I thought it was For Whom the Bell Tolled by Metallica because they start out very similar.
Yeah.
My friend's like, you dumbass, that's Hell's Bells. I'm like, oh, they sound the same.
Yeah, they're related content, definitely.
Yeah. Like, wow, that was.
Huh. All right, back to math. We saw the histograms were quantitative. They had to have numbers. So numbers only. But on the bar plot, we could do qualitative or quantitative. Some things you may not have noticed, because I didn't really show them. Histograms have to have vertical bars only. But bar plots can go horizontal or vertical. We've all seen bar plots where the bars go from left to right. Finally, we've all seen bar plots where they got some shit going on like this. And then they do a different color box right next to it. That's multiple data sets on one chart. But histograms, it's only one data set per chart. Because they're touching, and then it would be very confusing if it alternated what thing they were talking about. With the gap in between the rectangles, we can have one column for guys and one column for girls, and people follow along. Histograms doesn't work that way. I mean, you play Hell's Bells later. It's going through my fucking head now. I don't know how. No, I do know how it popped in my head. It's fucking Betta's fault. She's got the fucking AC/DC shirt on. And I didn't start doing it until I walked by her going to the bathroom. It was not in my head before that. I know it's her. All your fault. I enjoy it. I'm just gonna have to go listen to it. Maybe we'll play that at the beginning of your guys' midterm.
I have it on my phone.
Do you?
Yeah.
I'll just put it on YouTube. All right, you guys ready for more? Okay. Wait, I see some pins still moving. Some people didn't say no when I asked if you're ready for more. This is your chance to say, no, I'm not ready. Hold on a second, Mr. Jones, you're going too goddamn fast. I don't see the pins moving anymore. If you need it up longer, you need to say something. What?
Still I remembered it.
All right. So how do we get to these? We can go graphs, bar plot. And then we have the option for with data or with summary. For histogram, we were not given that option. It was just graphs, histograms. With data means you have every person's entries. What's a summary on an essay?
Brief recap of what the essay, or what you talked about in the essay.
It's a brief recap of what happened in the essay. It's usually in the spot of the conclusion. Summary here is the same thing. It's a recap or like, so number summary. It won't list everybody's information, but it might be like frequencies. That's a form of a summary. It might be other shit like that, means stuff like that. So like with summary means like we don't have everybody's entries. We just have like values listed. You're very rarely going to use with summary on these graphs. Normally when you do these, you have the data. Now, I want to show what's going on with bins real quick. And to go do with that, I'm going to actually put them back up and show you what's appearing on the screen so you can like make a connection. That's an interesting way to write. She's got her glasses like this.
Yeah,
She's all looking through them all fucking crooked.
I need bifocals.
Have you ever worn bifocals?
Yeah, actually trifocals, yes, and these are my old. I can see them on.
These are progressive bifocals. I don't use them that way. I only look through the fucking top because the bifocal part that is actually readable is like the fucking bottom millimeter. I'm like basically doing this and having a book like this trying to fucking read like that. That doesn't fucking help.
Yeah.
I guess regular bifocals where they have, you see that clear line, that would be better. But I don't want to look like that old. That's the fucking old man look. Fuck all that.
I have the blue light. Blue light for mine, because I work on a computer all day. Top is talking, and then the bottom is reading.
Huh.
On the progressive.
Interesting.
I got them through Stanton Optical.
I didn't know they did like blue light for part of it and not blue light for the rest. That's handy.
Yeah, like they'll take a dummy pair of glasses or whatever they call it, and then they'll actually they'll draw with the red line where it's gonna go, and then
Nice.
put your prescription. It's pretty cool. Of course, the part that sucks is the shooting in the air in the eye, and that is stuck.
I hate that. They're like, keep your eye open. I'm like, I know what's fucking coming.
Yeah.
And I can't. Everyone fucking blinks. All right, so both of these, if I put the cursor, oh no, BarPlot doesn't show it. So this kind of is important on histogram. See how it says parentheses 15, 20? The frequency 79 is the number of people that responded. The 15 to 20 says 15 to 20 rolls. If I look at the next column, it says 20 to 25. Well, where the fuck is the 20-year-old going? Is it going in this column? Or is it going on the one on the left? That's what we're gonna talk about. So this leads to the idea of binning. When you have too many different data values, the graphs have like fucking 40 bars. And that's not helpful. It's just you can't make the graph big enough to make it usable. Ugh. Yes, I spelled out ugh. I don't know if that's how you spell ugh, but that's how I spell ugh.
Like, yeah.
I could have gone with meh.
Hey.
All right, so what do we do about that? We do bins. You know what bins look like. Usually they're in your garages. They might be in your fucking closets. You throw shit in them, right? They store shit in them. So what we do in stats is we throw number ranges in these. One number range goes into one box, one goes into the next, and that's how they're sorting the data. So this is a way of making less bars. It's very much like doing laundry and putting them in your dresser drawers. Now, once you get to a certain age and you've collected too many fucking socks, your socks go in a different drawer than your underwear. Before then, when you're like younger, you might be using one drawer for socks and underwear, but usually you get old enough, it's fucking separate. I got a whole drawer for socks, a whole drawer for underwear, and like a drawer for shorts, and each drawer has its own thing. And only a freak mixes and matches. No one puts their fucking underwear in with their fucking shorts. That's confusing. Because you don't want to go pulling out a fucking short and you're getting dressed in the dark because your wife's sleeping and you just put on a pair of underwear and you walk out the door looking like a fool. We keep our shit organized, separated. Each thing's guy goes in their own box. That's what happens with numbers. So I'm gonna like list the number ranges that showed up in the data here. In fact, maybe I'll do it on a different page because I think I'm gonna want to write more than this page offers. But that's okay. I can leave that where you can see it. And the first number range here was 10, 15 like that. Then there was a 15, 20. Then there was a 20, 25. Then there was a 25, 30. And this list kept going on all the way down and got down to 75, 80. This was ages in our block, in our picture. This is what StatCrunch shows. Mathematically, this is what it means. The bracket means include the value in your number set, include the value in your range. And the parentheses means don't include it. Just get really close. That's for parentheses. Now, in statistics, they're always in this order. In mathematics, we could put the bracket on the right and the parentheses on the left. They could both be brackets, but for you guys, it's always going to be bracket on the left, parentheses on the right. What this means is this first group goes from 10.0 all the way up to 14.99. And 15 goes here in the next row. 15 up to 19.99. Just a little bit below 20. And then the 20 to 25 will go from 20 to 24.99. And so on and so forth down the list. In fact, this is the way the homework wants it. Homework will ask you to enter it like this. I think I need to scrap this red pen. I don't see Jessica here. She must be online. She is online. Jessica's the one that asked me about meeting at Starbucks. You guys thank Jessica when you see her for reminding me I wanted to do this. She tracked me down yesterday, hunted me down on another day. I think it was that Jessica. I think she's in the 5 to 7 class. I have a stats class in the morning, so, but I don't know that I have a Jessica in there. Mathematically, the way we would show this would be 10 is less than or equal to the age, which is less than 15. So if you know what these symbols mean, this is what's going on. We do use these less than or equal to, or less than and greater than signs throughout this course. So hopefully you know them. If you don't, I've talked about them in the support course. You can look through some of the clips about them. You don't even have to look at the video. You just skip through the paper like I scanned.
So it's basically, if you're looking at which way it's pointing, that'll be like if it's pointing left, it's gonna be less than. If it's pointing towards the negative numbers or going back, and then if it's pointing to the right, then it's gonna be greater because it's gonna be expanding down the line, getting bigger and bigger.
The numbers to the right, the mouth opens towards the bigger numbers.
Yeah, that's what I remember.
It's an alligator.
Okay.
I like to think vampire, Pac-Man, but alligator works. I say alligator a lot, but I want to be a vampire. Like, there's two outcomes for my life that I want. I either want to live an exceptionally long time by being a vampire, which I don't want to be a zombie because zombies, they don't have a brain. I want to be able to appreciate the future. I don't know that I'd do very well as a vampire because I'm not very fast. And unless I get vampire speed like they have in TV shows, I would not be good at catching food. The other option for my outcome in life is I'd like to be assassinated.
Jeez.
And I get a lot of what the fucks with assassinated. There is a difference between being assassinated and being murdered. There's a key difference. The outcome is the same. It's the reason. Who gets assassinated? JFK got assassinated. Important people get assassinated. People that have made their mark on the entire fucking history of the world get assassinated. You know who gets murdered? Everybody else. You only get assassinated if you're important. And more often than not, it's quick and you don't know it's coming. Murders, sometimes murders can be quick and not know it's coming. But Not necessarily. You could be fucking tortured for days on end before they finally kill you. Double tap to the back of the head because I'm fucking famous and I go down the history book. I don't know what it'll be for yet. I don't see that happening. So I'm rooting for vampire at this point. All right, so that's kind of how the binning works. This number on the left, we call, these are called bins or classes. And so they call the number on the left the lower class limit. And the number on the right is the upper class limit. How wide are these number ranges? They're 5 each, right? It's kind of easy to tell in some cases. If you can't tell how wide they are, there's a way of calculating it. To find the width, it's called the class width, but usually just abbreviated width. You subtract 2 consecutive lower class limits. Consecutive means one and the next one. From our example, I can do 15 minus 20 or 15 minus 10. I could do 20 minus 15. I could do 25 minus 20. All of these equal 5. If you need to find the midpoints, ooh, everything went fucking pink. The fuck happened here? Clear. There we go. Ugh. Ow, fucking cramped my hand taking the cap off. It was all like it was glued on. Oh wow, look at how small that, look how tiny that is. I haven't busted down the tip yet. The midpoint is you're gonna add 2 consecutive limits. And divide by 2. I'm going to show examples on the next page because I think it's like which 2 you use matters. So maybe I better show it. Is that too small for you, Angel?
No.
I can use the big old fucking super red marker that's dying. I'll eventually break this one down.
Bust it down, Mr. Jones, bust it down.
I don't want to bust it down. How about I just... Yeah, that's too much.
I have a question. On the first sequence, 15 to 10. I mean, like, I got lost there because the numbers have been increasing.
It was 15 to 20. Here I'm subtracting. I said subtract 2 lower limits.
Okay, thank you. I'm sorry.
Oh, I'm off the screen. Sorry, there we go. I zoomed in too much.
Okay.
See what I'm doing? I'm actually subtracting. 15 minus 10 is 5. 20 minus 15 is 5. 25 minus 20 is 5. They're all 5. It's all good. So I might have zoomed in a little too fucking close. I got a little excited. I get loud when I get excited. Oh, what was I gonna say? Okay, so we had 10, 15 like this. And I have 15, 20 like this. And I have 20, 25 like this. I'm showing midpoints right now. So if I want to find the midpoint for this region right here, midpoint, I am going to add the 10 and the 15. So this one and the next. This is 25/2, which is 12.5. Notice the 12.5 is between 10 and 15. It's like halfway between 10 and 15. And that's the point of it. We're finding the middle point. This, if you do it in a calculator, there's two ways of doing this successfully. You can either do 10 plus 15 and then hit equal sign and you'll get 25, and then hit divided by 2 and you'll get 12.5. The other way of getting this is if your calculator has parentheses. That'll get you 12.5. If you just type in 10 plus 15 divided by 2, it's going to give you 17.5. Because without the parentheses, the divided by 2 is only applying to the 15, not the 10. So the top two ways work in a calculator. This is bad. Bad juju. Don't do this. Now, if I want the midpoint for the 15 to 20, I'll do 15 plus the next value over 2. Is 35/2 is 17.5. That's doing this one's. This one, I'll do 20 plus 25/2, which is 45/2, which is 22.5. Something you might like. Once we've done the first one, to get to this one, all I got to do is add the width. To get to that one, add the width. Adding 5 is a lot faster than adding two numbers together and dividing by 2. I don't know if any of the homework problems have it on there, but that's the shortcut of doing it. StatCrunch allows us to, in histograms, we can set the starting number and the width. Fuck, I'm writing like I can't, know how to, like I don't know how to write. We can set the starting number and the widths. And I'll show you in a second. And there's a reason for this. Sometimes we want our data grouped up in a certain way. Here's an example. Completed semester units. There are two good bins that work. 12 and 15. These are good bin sizes for completed semester units. 12 is because that's considered full-time enrollment. Not a lot of students take 12 units. Because if you want to graduate or transfer in 2 years, to transfer with 60 credits in 2 years, two years is 4 semesters. We need 60 divided by 4, which is 15. So if you want to graduate or transfer in 2 years, you need 15 units a semester. That's transferring with 60 units. STEM majors generally get the fucking shillelagh on that. They are fucked. So do nursing students. I guess that's a STEM field though, but You really are doing, biology and fucking medicine. Other people, if you're transferring in 60 units, and so like. Like 7 or 22 don't make sense. There's no reason to pick these as bin sizes. They don't relate to anything that we know. A lot of times, you will pick the bin size for like whatever project you're doing to try to get a feel for what the graph looks like. And I'm going to go over like graph shapes in just a little bit. In fact, let's go over graph shapes now. I normally wait and do something else first, but this is the good segue to the graph shapes. I don't know why I've never done it in a different order. So I'll give everybody a chance to write this down and then we'll go graph shapes. Wait, maybe it's for whom the bell pulls that plays the fucking bell in the beginning.
I think they both do. It's just until it gets into the, to the actual music part, and that's when I'm, it's either this or that.
Oh, now I gotta listen to both. Because it does, there's a bell tolling in it.
I've always enjoyed In Truth the Sand.
I like it, but I feel like that's like it was overplayed.
Yeah.
I had Master of Puppets going through my head the other day, about 8 a.m. I don't know why.
And then the rare one is Fuel.
I haven't heard that one.
It reminds me of a race car.
All right, you guys ready to see some graphs? Why am I bringing this up? Let's look at some typical graph shapes. And I'm going to do these all with histograms. If the bars are all about the same height, we call this the uniform distribution. This happens when you pick things that occur that are equally likely. Like if you're rolling a die, I'll say dice because most people don't think of die as a singular of dice. If you're picking cards from a deck, the suits are just as equally likely to appear. So when we think of uniform, we tend to think of like police uniform, firefighter uniform. They're called uniform because they all look the same. The bars all look the same. They're all roughly the same. Then one of the two that I hate. The bars on the left are color. This graph is called skewed. Let me if I can spell it right. Skewed right. Drives me nuts. We're gonna talk about this again on Tuesday in 3.1. We're gonna go into a little bit more into the graphs, but I think that the more you see these, the more accustomed you get to knowing what they are. This happens with like housing prices. Income. A lot of people make low and middle, and very few people are fucking Bill Gates. No, a lot of people don't are super wealthy. Children, number of children you have is like this. There's a lot of zeros, ones, and twos. There's a few 3 or 4. Every once in a while, you get somebody that's got like fucking 9 kids. I remember one student saying at one point they had like 15 siblings. And I fucking just like my head like blew up. I'm like, you that poor mother. You know dad ain't staying home enough to fucking take care of that many kids. Mama gotta raise fucking 15.
You guys gotta provide for all 15, that's why.
Yeah, he's out, but yeah. But he's gonna have to be providing for the family either way. Like there's fucking 4, there's 15.
It's even that much harder, 2 jobs, full time.
You might have to do 2 jobs or just get a better paying job. That's a lot of kids. Unless you have like octuplets or some shit like that like rapidly speeds it up. That's also a lot of years of just being pregnant. Thank God I'm a guy. Fucking that pregnancy shit sounds lame. Sorry about your luck, ladies. Thank you for your service to all of mankind now. Thanks for taking one for the team. That's right. Y'all do to keep us going. We appreciate that. That's why Mother's Day is so much more popular than Father's Day. Right?
Yeah.
Father's Day does not get the love Mother's Day does.
That's sad.
Well,
But
mothers tend to spend more time with the children than fathers do. So the kids have a closer bond with the mother. Just tends to be even most families. It's not all true in all families. Sometimes mama's bringing home the bacon and daddy's staying home and raising them. But the stereotypical one, and we'll use stereotypical because it is stereotypical. It's not everyone. The guy goes out and brings home the bacon. For a while, my wife made more than me. I said, oh, hell with that. I gotta go get a different, going back to school. Not why at all. That isn't why at all, but it sounds fucking very chauvinistic. And so every once in a while, I like to just be a jerk. All right, so bars on the right or bars are on the left or taller. It's called skewed right. Guess what happens when the bars on the right are taller? What do we call that? Skewed left. So we got little bars over here. There can be gaps. And there can even be little ones to the right. But the hump is on the right. And we call that skewed left. Now, categories for this, GPA at graduation is a good example. And at graduation is the key part of that. Lots of students have very, very low GPAs. Very few of them continue all the way to graduation. If you're sitting there on a 1.6, where you're getting more D's than, you're getting almost as many D's as you are C's, or you're getting B's to compensate with F's, you tend to give up when you're failing a lot of classes. You just quit. You're like, fuck all that. This is not, I don't like this. School isn't for me. So people that graduate tend to lean towards the right, 3.2, 3.4. You have people in the 2.5 and 2.6 and the C range, and they happen, but like the people are most likely to graduate are the ones that are in that 3 and higher area. Another this sad category is really sad, but age at death. A majority of people live to old age. There are some people that die at middle age, and there are the tragic few, the infants that die. We do have infant mortality. Thankfully, most of us live to an older age. Very few of us make it up to that fucking 101 slot. You know, those people that live to be a fucking centennial, have 3 digits in their age. I don't even know if I want that unless I'm a vampire. Cause like that's the age where like they don't have an easy time paying attention or like remembering people's names and shit like this. It's just been too long. I don't know. The diaper wearing years. I don't want that. Vampire me. That's the skewed left graph. Then we have our the blessed graph. This is our blessed graph, where there's some lows on both sides, but the good shit's in the center. And it doesn't have to be perfectly like that, but the hump is in the middle. This is called bell-shaped. If I draw a bell over the top of it, like the tops of the chart or columns tend to hit it. Things in this category are things that where there's like, most people are in the middle. Weight, height, shoe size, IQ. Yeah,
What's the graph called? Is it called bell-shaped?
it's called bell-shaped. Because you can draw a line over it that looks like a bell and it hits the tops of the columns. It's called bell-shaped. This one is called skewed left right here, because if I do that where I'm trying to hit the curve, hits the top of them. These are the things on the left and the right are called the tails. And on the skewed left one, the left tail is longer. That's why it's called skewed left. It's terrible. Why are we thinking about the shit that's at the edges of the graph rather than where the hump is? In my head, I constantly think of that and go, that's on the right. And I have to tell myself it means the exact opposite.
Yeah, it's feeling too.
It happens. But if I accept that, accept the way my brain works and go, just think it's the opposite of what you want to call it, I can remember that. Same thing happens with skewed right. If we do the thing right here, the tail on the right tail is long. Why don't we take a 5-minute break? Let people stretch their legs, use the restroom. We will be done early, but we do still have more